Hey, it's Mr. Snyder. Today we're going to be talking about solving system of equations using an algebraic method called substitution. So we're not going to be using a calculator today. We're just going to be doing everything using algebra, okay? To do substitution, what you're going to want to do is get one of the equations and one of the variables in one of the equations isolated, okay? You'll notice that the top equation, one of the variables already is isolated, and it is y, okay? So we're going to, for the most part, take what y equals in the top equation, okay, y equals 3x minus 2, and we're going to take that and plug it into, or substitute that into the second equation, okay? So I'm going to go ahead and do that. Before I do that, what I normally do is I put parentheses around my y in the second equation, and for the most part, treat that kind of like a garbage can, and I'm going to stuff that garbage can full of whatever y equals, and again, y equals 3x minus 2, so I'm going to put that in there. So here we go. Let's get started. So we got 2x minus 3, and again in this parenthesis I'm going to shove what y equals, and y equals 3x minus 2, so I'm going to put it in there. So 3x minus 2 in the little trash can's gotten bigger, negative 8. Now I have an equation to solve for with just one variable, which is possible. We've been doing this. So let's go ahead and do that. Alright, so I got 2x. I'm going to rewrite that. I'm going to distribute the negative 3 in here. So I got negative 3 times 3, which is negative 9x. And I got negative 3 times negative 2, which is positive 6, okay, equals negative 8. Okay, I'm going to simplify a little bit, combine like terms. So I'm going to end up getting negative 7x plus 6, because 2x minus 9 equals negative 7. Equals negative 8. Now I'm going to move that 6 over to get that negative 7 by itself. I'm going to do that by subtracting 6 from both sides. And I get negative 7x equals negative 14. This is looking like it's shaping up to be a pretty nice problem. Okay, so I'm going to divide both these sides by negative 7. Negative 7 over here. These will cancel. I get x equals negative 14 divided by negative 7, which is just a positive 2. Okay, so I get x equals 2. Now, if you remember back when we were doing this with graphs, our solution was an intersection point. And intersection points actually have two parts to it. They have the x-coordinate and the y-coordinate. I just found the x-coordinate, so I need to find the y-coordinate. To find the y-coordinate, what I'm going to do is I'm going to plug in what we just found x to equal, back into one of the original equations. Now, since this top equation up here is already y equals, it's pretty much set up very nicely to just solve for y. So what I'm going to do is I'm going to just rewrite this, but instead of having x, I'm going to substitute what x equals, which is 2, okay? So I'm going to put this right here, and I'm just going to go ahead and say y equals 3 times x, and again, remember we just solved for x, it's 2, so I'm going to plug that in for x, minus 2. 3 times 2 is 6, minus 2 is 4, so I get y equals, oh, that's an ugly looking 4, I'll get y equals 4, alright? And that is my two solution points, or two solution parts. So I got the x equals 2 and the y equals 4. Now, to write this super nice, I'm going to write it just like I did when I was solving it when graphing. I'm going to write it as a point. So the answer to this system of equations is 2 comma 4. Okay? Awesome. Let's go on to the next example. The next example is going to be a little bit more tough, because if you look at these equations, we don't have a variable isolated yet, okay? So what I do is I try to scout out the nicest like isolated variable, and yet again there's a y that looks pretty lonely right over here in the 2x plus y equals negative 1 thing. But again, y isn't by itself, so I'm going to have to move this 2x to the right side, okay? So what I'm going to do is I'm going to rewrite this 2x plus y equals negative 1, and I'm going to subtract 2x from both sides to get that y isolated, or y by itself. I'm going to cancel that. I'm pretty much just going to be left with y equals negative 2x minus 1. Now I have an equation just like last time, and I'm going to focus on this new equation here as my, for the most part, clue. So y is going to be equal to negative 2x minus 1. Now I haven't really changed the equation. All I've done is just rework it and make it look different so that it's just y isolated, okay? Now I'm going to plug y and the values of y, negative 2x minus 1, into the other equation, the second one that I haven't touched yet, and let's rewrite that with everything written in there, okay? So plus 3. Now, in place of y, I'm going to put this negative 2x minus 1. And then I'm going to say equals 3. So I've successfully substituted what y equals into the other equation. I just have x's now, and now it's looking a lot like the problem we did before. Okay, so let's just go ahead and finish this out. I got 4x. This is when I distribute this. 3 times negative 2 is going to be negative 6x. 3 times negative 1 is just going to be negative 3, and I get that equals 3. I'm going to simplify. 4 minus x is just negative 2x. Minus 3 equals 3. Okay, I'm going to add 3 to both sides. Okay, put my little line there. Okay, I got negative 2x equals 6. I'm going to divide each side by negative 2. Boop-a-doop-a-doo. And I get x equals a whopping 6 divided by negative 2, which is a negative 3 for my x coordinate of the point that I need. Now I got to go ahead and get my y. Okay. Notice how like that first equation we kind of moved everything around so it was a nice like y equals equation. Well, I'm just going to use that new and improved y equals equation part to plug my x into to get y, just like I did for the other problem. So I get y equals negative 2 plugging in my x, which is negative 3 minus 1. Negative 2, using order of operations, we do multiplication first. Negative 2 times negative 3 is a positive 6 minus 1, and that's going to give me, or that's going to give me, gotta learn English, 5. Okay, so there's my 2 points, negative 3 and 5. So I'm going to write that the fancy way, and the crowd goes wild. Yeah. Okay, that's the second example. One more example today. Let's go to example numero tres. All right, last example. Okay, so we got 3x plus 2y equals negative 3 and negative x plus y equals 11 over 6, okay? Again, the nice thing that we're going to do, or the nice variable that looks like it's ready to be isolated, is this y here. It seems like all these examples we're isolating y. Again, it really doesn't matter which variable you isolate. You just have to pick the equation of the two that has the nicest variable kind of by itself, all right? So this y is all by itself. We're just going to move this x over to the right side. So I'm going to add x to both sides. And that's going to result in the equation y equals 11 over 6 plus x. Okay, so that's going to be my new and improved isolated variable equation. All right. We're going to use that information, 11 over 6 plus x, into the equation we haven't touched yet, which is up here. The 3x plus 2y equals negative 3. Okay, I'm going to plug in the y information into that. So let's rewrite that. So I got 3x plus 2 times y, but instead of writing y, I'm going to write what it's equal to in the other equation, 11 over 6 plus x, parenthesis, okay, equals negative 3. Okay, now I'm going to go ahead and distribute this 2. So I got 2 times 11 over 6, which is just going to be 22 over 6. We'll simplify that on the next time through, plus, whoopsies, 2 times x, which is going to be 2x, equals negative 3. Okay, now I'm going to combine like terms and simplify this fraction all in one step. Whew, hopefully I don't make a mistake. So I got 3x plus 2x. That's going to give me 5x. Okay, and plus I'm going to reduce this fraction by dividing the top and bottom by 2. So when I do that, I get 11. And then 6 divided by 2 is just going to be 3. So I have 11 thirds as my fraction, equals negative 3. Now, to get rid of my fraction, what I can do is multiply both sides by the only denominator I have there, which is 3. So I'm going to do that because I hate fractions. So here we go. Multiply this time by 3, boop, and multiply the other side by 3 and distribute that in. So 3 times 5x is just going to give me 15x. And then 3 times the other one, well, the 3's are just going to cancel because 3 divided by 3 is just 1. So it's just going to end up being 1 times 11, which is just 11 itself. So plus 11 equals negative 3 times 3, which is going to be negative 9. All right. Now I got to move over this 11, so I have to subtract 11 from both sides, and I'm going to go ahead and get 15x equals negative 9 minus 11. Okay, which is going to be negative 20. Okay, I'm going to divide each side by 15. And x is going to equal negative 20 over 15, or if we simplify, negative 4 thirds. Okay, so this is going to be negative 4 over 3. Okay, by dividing both the top and bottom by 5, you can get that. All right, so x is going to be -4/3. Let's go ahead and plug this back into this isolated y equation and solve for y. Okay, so I get y equals 11/6 plus, now I'm going to do a plus -4/3. You could just say -4/3, but for the sake of this, I'm just going to go ahead and do it this way. -4/3. Now I have a fraction problem. Yuck! I'm going to have to get common denominators now. The common denominator that I'm going to work with is going to be 6. So let's go ahead and do that. I got y equals 11/6. I'm just going to write minus now. To get to 6, I have to multiply 3 by 2. So I'm going to multiply the top by 2 too, and it's just going to be 8. 11 minus 8 is going to be 3. So I got y equals 3/6, which is reducing down to 1/2. So my final answer for this problem is just going to be -4/3 for my x coordinate and 1/2 for my y coordinate. Okay, and there is my answer for the third example. All right, so hopefully that helped you out a little bit. If you have any questions, call me on over. But that's for the most part how we do substitution and using substitution to solve system of equations. All right, see you later. Bye-bye.